Hello and welcome to the Manroland Goss Web Systems webinar series. My name is Joe Moretti and I'm the Senior Electrical Instructor here at Manroland Goss. Today we'll be covering webinar number 10, that is a unit electrical training program. This is the second of a two-part series we currently offer for the service technicians. The first of the webinars is the Siemens Basic course that covers the Siemens PLCs and the Siemens motion drives that specifically control your press equipment. This webinar is a supplement to that basic Siemens course that ties all the hardware components you've been exposed to and puts them together in a system controlling your web press equipment. Some of the equipment covered are the Sunday 2000s, 3000s, 4000s, 5000s, the M-Series 500, 600, and 800, and the VPAC 500 and the VPAC 3000. The following information will explain the different systems and how they are addressed in the electrical training course. First, I'd like to introduce you to the Manroland Goss Web Systems. We're currently based out of Durham, New Hampshire, and we are the industrial leaders of commercial and newspaper printing presses with over 15,000 web offset printing units installed since 2000. And currently we're the largest support and service group in North America. Whether you are a new customer purchasing your first press or an existing customer, we strive to put the customer first. Manroland Goss takes pride in prioritizing your needs first and foremost. From start to finish, Manroland Goss can provide expert support on installations, enhancements, rebuilds, relocation services, and spare parts. Factory support is always standing by your side. The Manroland Goss webinar series is designed to inform the customer of services available from the Manroland Goss team, whether on-site or online, to keep your equipment performing at high levels and being profitable. Preventive maintenance and intimate knowledge of your equipment will keep operation costs and downtime to a minimum. Today's webinar introduces the electrical spectrum to the service technicians responsible for maintaining your equipment. Manroland Goss' state-of-the-art control system has many different modules working together. Your technicians working with the training team can effectively absorb the intricate knowledge of all components. Downtime can be minimized and it will be reflected in your press uptime. Our professional training instructors will keep the students immersed with both hands-on and classroom material. Courses are custom specific and tailored to get the most out of their relevant CSO material. Their actual schematics and assembly drawings in the print units, drive cabinets, and consoles will be covered. On-site hands-on requires minimal downtime around production schedules, with hands-on training where real work experiences for the technicians is very important. Production improvements will depend on the skill set of the technicians and their ability to troubleshoot effectively. The learning curve on this equipment is vertical. Training can provide the tools for the technicians to start developing their skill set. A solid foundation is important to formulate a path to accelerate skills. The student will learn to troubleshoot utilizing the tools available to them. They need to understand the complete system so they may quickly narrow down the problem. Studying the architecture and understanding primary functions is key to being successful. Electrical crews will have to address control systems as PLC drives and human-machine interfaces, HMIs, along with components as sensors and actuators. A checklist as displayed is a good tool to develop a preventive maintenance program, refresh your memory, or to train new technicians. A high-level list can verify each system function, and a lower-level list can address more specific components such as direct I/O, overload settings, and safety switches. This example would be part of the hands-on training where the student could check off items when complete verification of each system is completed. Designing a specific list for your equipment is time well spent. During the training, we will start with the hands-on practical approach of troubleshooting with schematics and multimeters. We will utilize tools available from the operator screens as faults and alarms are displayed for both the operators and the technicians. The PLC module that generated the fault along with the actual tag will help the tech narrow down the problem along with the fault history library displaying details and the time of the error. On some presses, there are diagnostic panels available on the drive cabinets graphically displaying live I/O. Diagnostic LEDs on the hardware can display power, internal faults, and errors to the system. We'll move to the more intricate tools as the diagnostic buffers and the hardware configuration tools displaying the networks in the Siemens PLC with the S7 software. Starter software will also be used to view drive topology, networking, status and trace functions to check the actual drive and motor performance. The student will learn every component on the press and understand its functionality. One-on-one with the schematic and assembly drawings, we will start with the power distribution through to the safety redundant systems. Some of the features covered will be direct and remote I/O, inking and dampening systems, blanket change, lubrication, plating, and registration will be covered intimately. A thorough understanding of the press functionality, such as the operator has, is valuable for troubleshooting. How an advanced system is supposed to work and where the process is failing. Understanding these will help you isolate the individual components linked to that function. A good example could be a blanket change sequence. A lift mechanism swaps states, door locks open and verifies a switch. Door opens only if the main door shield is closed, and the blanket plate enables the operator to remove and install plates. Understanding the expected process will help you quickly address necessary component adjustments or replacements to place the equipment back into service. The auto plate functions are additional features on some of our equipment, as the 600s, 2000s, 4000, and 5000 presses. Some of the additional specific components may be stepper motors and drives, vacuum generators, linear slides, solenoid valves along with flow valves, proximity switches, and safety mats. These components have to be adjusted correctly and working together. Additional inputs from the control panels for this functionality also include some manual sequences to use in testing all the functions to provide successful automatic plating. The main drive motors must be positioned accurately for this proper plate installation, so zeroing the motors is critical for this procedure and will be covered. The next several screens will review some of the higher level processes in the press and their components. First, the blanket door and the lift mechanism. Some of the press systems have automatic doors with backup safety switches to verify the status of the press. Limit switches reporting to both the unit PLC and the safety PLC need to be reviewed. Switches in the gear tub verify the status of the lifts prior to the door opening and production ready status. Locations of these solenoids and I/O will be identified and tested. Next, we have the dampening system and the associated components. There are several components such as the solenoids, clutches, level sensors, and limit switches. Micromaster frequency drives mounted on each unit drive the dampener form and water pan rollers that is tied together with a DC bus link. Schematics will be reviewed and I/O points identified and verified. Next, we have the press cooling system. A central cooling system of chilled water is pumped by a MicroMaster frequency drive into the system cabinet. Schematics and assembly drawings will be covered. Flow meters on the chill system allow the press to be enabled. Chilled water is distributed to the rollers and the heat exchanges at the unit. Some of the Siemens main drive motors are water-cooled from a separate system. Some auto transfer systems also preheat cylinders, prepping them for quick production. The lubrication systems. We discussed the chiller and heat exchangers and how they cool the oil in the gear tub cascade system. The schematic for the oil pump circuit is explored that enables a motor with verification from a flow meter and a tempering valve controlling the temperature. The tray-bound automatic grease systems is also covered. This lubricates the bearings to distributors on the units and associated I/O. The ink systems on the Manroland Goss presses come in two types, open fountains and digital inking. We will be covering the embedded controller boards that runs the system, review Ethernet network and components, embedded controllers mounted on the units, channel driver boards, and the individual ink keys. The functions on the HMI for the operator to automatically or manually manage the keys and the procedures on ink key replacement will be covered. Procedures as calibrating keys and utilizing the closed-loop color, CLC, are also covered. Typically, the unit electrical class is studied after the basic Siemens PLC and drives course that covers individual hardware at the component level. Here we will cover the architecture of what we call the Omnicon Evolution Press System, that we tie all the components together. Server, consoles, unit, system, folder, dryer, and reel stands as a complete system. We will introduce you to the networking, all interconnecting wires, and the safety features with assembly drawings and schematics so you can understand and troubleshoot the system as a whole. As a technician, you will have to know where the software is located for backups and how to reinstall the software to get the systems up and running quickly, and how to replace the component failures and make sure that they are commissioned properly. All these need to be done in the system, the unit PLCs, drive controllers, redundant safety PLCs, frequency drives, stepper drives, and communication modules. The drive networks. Drive systems are not mechanically connected, but electronically coupled through software and some intricate networking. We will cover the in-depth details with the schematics and assembly drawings of what the networks are. Students will learn how these networks can be verified, such as going online with the software topology and making sure that they are connected properly for drawing. We will talk about the DC bus links, the diagnostic features built into the drives, and how to monitor them as far as trace functions that can help troubleshooting as the press is running. Commissioning procedures. Exchanging components, in most cases, is very straightforward. However, there are some components that need to be set up properly or recommissioned when they're installed. Typical procedures would be changing the main drive motors or encoders, for they have to be re-zeroed as the offsets are needed to synchronize the press. There is a proper procedure for downloading the PLC controllers so the proper hardware and user programs are accurate and working properly as a system. Loading some motion drive controllers from memory cards has specific steps to introduce the licenses. MicroMaster frequency drives are loaded remotely from the main controllers. Registry replacement or adjustment must be recalibrated. Smart actuators with stepper drives, if replaced, must be loaded with proper parameters and addresses. Calibrated components. Again, depending on what you have for equipment, there is calibration needed on some of the modules. Registers, once they are reset or installed, must be calibrated, for the position is not broadcast by any type of encoder. Smart motors in some cases have soft stops built into the software to shut them down at their limits and need to be set up properly. Some of these can be done from the operator screen, where others have to be triggered manually in the PLC controller. The display on the screen is showing the unit calibrations for the upper circs and the laterals on the print unit number 1. Here you have to go into the software to trigger the function that records a time value from a known position to be used at a later date. The schematics. During the class, we will be spending a lot of time in the schematics reviewing the components and their specific details addressed in them. The picture on the screen is showing the oil pump motor starter components mounted in the back of the units and the associated motor starter and thermal overload symbols assigned to them in that circuit. We will be covering the printing units, the system, unit, and folder drive cabinet schematics in detail. We will also address the hardware safety loop going through the press and going out to the redundant PLCs. Some of the material is not displayed on the schematics and must be extracted from the assembly drawings. The schematic and assembly drawings may need to be reviewed together. Assembly drawings. Assembly drawings are a great tool to get down to the component level. Not only do they show you the actual component, they show you the part number of the component, where it is assigned to in the cabinet. It also shows color coding on some of the wires, the wire numbers, and the wire termination points. These details are important, and many of these are not displayed on the schematics. You should be working hand in hand with the schematics when you're working with the assembly drawings. Some of the other important features of the assembly drawings might be showing the network layouts as PLCs and drives in local and in remote cabinets. A component-to-component troubleshooting tool like our wirerunit list, however, this is for the networks. Wirerunit list. Manroland Goss releases a wirerunit list for your specific equipment. The wiring list will show you point-to-point connections between the cabinets as main power distribution, system, folder, and unit drive cabinets, print units, etc. This document includes the wire numbers, wire size, colors, module and termination points of that module on either end. The Manroland Goss electrical team offers several unique service programs. Not only just training programs as the Siemens PLC controls and drive training classes mentioned before, but several other service programs. Some include preventive maintenance programs for both electrical and mechanical elements to keep your equipment running in top form. The electrical evaluation service of the press, checking the status and efficiency of many areas, and to also help address future obsolete parts and review cost-effective component upgrades. Evaluating communication integrity, the complete press such as Profibus, Profinet, and Ethernet networks to help reduce communication-related downtime. Thermal imaging to identify current and possible future concerns in your equipment. We offer a backup and storage service for your critical software, and of course, safety evaluation audits. To complement the services, we have a wonderful production service and support team here at Manroland Goss. I would like to introduce you to the FSA Flexible Account Program. Manroland Goss offers you around-the-clock on-site support worldwide to help keep your production schedules on track and equipment running. The Flexible Spending Account offers discounted field service hours used for a variety of eligible Manroland web system services and programs. Please contact Manroland Goss for more details and see if we can tailor a program that fits your needs. In addition to the FSA on-site service program, Manroland Goss also offers around-the-clock remote electrical service support program with VPN or dial-in support. Remote support technicians are backed up by the strength of the Manroland Goss Web Systems division to meet your remote support needs. Please contact Manroland Goss for more details and evaluate your best course of action towards cost savings. From A to Z, or start to finish, Manroland Goss wants to be your total solution provider. Whether you're looking to improve print quality, reliability, efficiency, or reducing downtime, we have the expertise to transfer knowledge and to be a proactive partner. In addition to the unit electrical Omnicon course we just discussed, we offer a PLC control and motion drives course covering the Siemens S7, PLC, Siemens Simotion, and master drives. Manroland Goss can offer you a custom course designed to fit your needs. Whether it is for your new technicians that have never been exposed to the equipment or the seasoned veteran that needs a review or upgrade in their skill set, we have the experience here at Manroland Goss to provide you with what you need. Again, my name is Joe Moretti, and I am the Senior Electrical Instructor here at Manroland Goss. Thank you very much for your time.